UK-Israel Precision Agriculture discussions. So I'm Karen Shurkin. I'm head of the Science and Innovation Network based out of the British Embassy in Israel. And we're working in collaboration on this event with the British Council and the World Foundation. We have here Ariel, our colleague from the Council, who's going to give you a bit more information about the World Clean Growth Alliance shortly. So the goal of this event is to promote UK-Israel collaboration. We're bringing together Israeli precision agriculture innovators with top UK universities and research centres. From the British Embassy perspective, this year is an exciting year for us. The UK are hosting the UN Climate Change Conference, COP26. That will be in November in Glasgow, and so a lot of our agenda focuses on climate science and climate innovation, questions on how does science impact policy, but also how do we encourage new techniques and new technologies to support the nation's adaptation and resilience strategies. The other thing is we really do believe that there's great synergy between the UK and Israel in this area. Both countries have farming and agriculture as a part of their DNA, as well as, of course, science and technology. Someone will correct me if my stats are wrong. Parmjit is going to present you a lot more on the UK's agricultural landscape any minute. But from what I could find, the UK employs over 4 million people in this sector, which makes up 14% of its employment workforce. And also in Israel, again, correct me on my stats, but 17% of Israel's total agricultural budget goes towards R&D. So clearly a real focus from both sides. So yeah, I really don't want to take up too much time. I'm just going to quickly move this little thing that's in front of me to just let you know what the agenda is. So I'm going to shortly introduce you to Parmjit, who will give an introduction on the UK agricultural landscape. Ariel will present on the World Clean Growth Alliance, and it's a great opportunity, a funding opportunity to support collaboration and enable research. So really happy to have Ariel here. And then, of course, a panel discussion from these hotbeds of agricultural innovation in the UK. So really not much more for me to say, because we'll hear from everyone. I'll quickly just take the opportunity to thank Hadar from the UK Israel Tech Hub for developing this program, a really efficient and effective program, hopefully, and I'm sure you'll find value. And also to Jane, I'm not sure if she's out there in the audience, from the Midlands, and all the colleagues from the Midlands for their support. So that's it from me. I'm going to hand over to Parmjit Chima, who's the head of engineering department at Harper Adams University in the Midlands in the UK. And thank you all again for being here. Thank you very much.
Thank you very much, Karen. So it's a pleasure to be here. And what I'm going to do is to give you a quick presentation of the UK landscape in terms of farming. Now then, let me just make sure that the tech keeps up with me. Yes. Hopefully you should be seeing something on your screens.
Parmjit, we do see. If you could just maybe put it in presentation mode, that would be great.
Yeah. Hopefully you see that.
Excellent. We see.
Okay. Thank you. Yeah, it's a pleasure to be here. And I'm just going to start off by talking a little bit about the UK agricultural landscape. It's vital to the UK economy. It has been for hundreds of years, ever since the Romans came over in 55 BC. There's been farming established across the UK. if we were to look at the UK map and look at the different types of diversification of farming, you'll see that we basically encompass quite a lot in the sort of topology and the geography of the country, because it's wet and dry in some places, it's wet and dry most of the time in some cases, but it can be, depending upon where you are in the country, quite flat, or it can be quite hilly or mountainous even. And then there's all different types of farming that can take place there. So if you were to look at this map here, you'll see that arable farming is largely concentrated on the southeast of the country, where the land is fairly warm and dry, the climate. The soils are fertile. But that's not to say arable farming doesn't take place in the rest of the UK. As I'm sitting here at Harper Adams University in Shropshire, I'm in the middle of a field. Effectively, and we have wheat growing on the one side, rapeseed or oilseed rape on the other, and then we have oats further down the road, and then it's mixed with livestock of all different types, sheep and cattle. So quite diverse in what we do in the UK in terms of farming. Just looking at some of the facts and figures, well, over 71% of the UK land is devoted to agriculture and farming. That's more than 20 million hectares of land. This is reducing somewhat through commercialization and urbanization, but you know, the figure is holding up quite well. In terms of the industry, over 293,000 people are employed in agriculture across UK, across the various sectors, with about 280,000 farms. And these farms are large, small operations. Some are even multinational operations. But we have, in terms of livestock, 59 million animals, and predominantly sheep, cattle being the two most popular. And in terms of the contribution to the UK economy, over 120 billion pounds is from the agri-food sector, so quite substantial. If we were to look at some of the crops produced, and that's in my next slide, and there are a range of crops that add to the economy, over 2.9 billion from cereals. There's 1.5 in vegetables and potatoes, and you can see the rest. So quite substantial numbers there. And 61% of the food that is grown in British farm is eaten in the UK. So we do have some imports from Europe, but from further afield also. But we are fairly sort of self-sufficient when it comes to providing food and resources for the consumer. Moving on a little, just to look at horticulture. So there is quite a big horticulture industry and associated industries with that. So quite a significant amount of income is generated by the activity, over 3.5 billion pounds. Employing many workers. Many are seasonal, yes. So over 40,000 permanent workers, 70,000 seasonal workers. So that is probably a figure that has seen some changes, you know, with the pandemic and the challenges we have all faced. There's been a reduction in the number of seasonal workers. And that's always been a factor in the UK horticultural economy. So having more seasonal workers, the ability to attract workers from parts of Europe, typically Bulgaria and Romania, has been a sort of a key foundation in the horticulture industry. But you know, there are advances in technology and engineering that will assist. And so this is one area that we are looking to sort of develop further in terms of providing solutions. So we produce around 56% of the vegetables that we consume, 16% of fruit. One of the fastest growing sector is vines for wine production. And I'm just going to give you a little bit of facts about viticulture in the UK. UK is probably perhaps not well known for its wine industry, but it's growing exponentially. There's over probably nearly 6 million bottles of wine that are produced every year in the UK, and the number of commercial vineyards has grown quite significantly, so over 500. Now exported to 27 countries, and with the latest trade agreement with Australia, I'm sure that is 28 countries now. So quite a range of grape varieties are planted or grown, and from where I am sitting in Shropshire, there's probably about half a dozen vineyards very, very close to me. Food and drink industry, just very quickly moving on to that. It's significant. It sort of has a gross domestic product which exceeds manufacturing, automotive manufacturing and the airline industry in the UK. 73 billion pounds. The stats you can see, it is a significant contributor to the UK economy. In terms of employment, over 440,000 people. We've spoken about the exports, not only in the UK market, but across the world, with the top export markets being Ireland, the USA and France. And hopefully at some point we can sort of bring Israel into there as well. So quite significant in terms of its impact and its global reach. So moving on very quickly to a little bit about Harper Adams University. As a university, we've been here for over 120 years, set up and predominantly for the land-based technology. So Harper Adams University, we're based in the Midlands, just north of Birmingham, about 50 minutes drive from Birmingham, very close to the Welsh border. So that's the sort of typical topography you will see of rural Shropshire. We occupy 635 hectares of land. So the university occupies about 20 hectares, and then we have the rest of it, which we devote to farming. So we are a farm, a commercial farm as well, having livestock as well as arable farming. We are also the home for one of the agri-tech centres. So the Agri-Epicenter is based at Harper too. So in terms of what we deliver, we teach agriculture, business, food, environment, wildlife, as well as a new vet school that recently established with Keele University. So in terms of agri-engineering, as I like to call it, what my department focuses on is a range of technologies. And what we try to do is to translate technologies from many other sectors. And I know Israel is very good at doing this too. And so I think there's a lot of synergy between the way we go about looking at system solutions. So I've predominantly worked in the automotive industry for a long while, and we're using some of their technologies and applying those to agriculture. And you can see the sort of things that are coming in there. Machine vision, IoT, sensing, artificial intelligence is being used in a big way. And more, navigation of various types, whether it's 4G, 5G, and satellite indeed. And we've got some experts here that will talk about remote sensing soon as well. So those are some of the solutions that we developed, needed by UK farmers and new emerging industries. So let me just very quickly go into this slide, which is looking at the connected farming of tomorrow. So where is farming going? Well, it may take a bit of time, but we have seen a plethora of small companies developing solutions for the farmer. And in many cases, they are actually the farmers coming to universities like ourselves and others in the UK and to the Agri-Epicenters looking for support and advice. And this is what we are looking to do, is to set up this ecosystem where we can give them the best of advice for developing the products and then taking them to the market. So are smaller robots a solution? Well, yeah, they will reduce soil compaction. And that has been a big factor in the reduction of yield. The yield in the UK has sort of plateaued over the last 5-10 years. And we are putting more and more heavy machines on UK soil and then having to do some real work to undo the damage. So smaller machines, well, they will help reduce compaction. If there are smaller machines, well, we can get better resolution. We can understand what's going on, say, perhaps to a plant level as opposed to a field level. If we're coming to use smaller machines, potentially electric machines, then there may be ways that we can make them work together. And there's lots of work being undertaken in the sort of automotive industry, looking at swarming. So these are convoys of vehicles operating together in a formation. Well, we can actually do that with smaller machines, make them work together collaboratively. And then there are other services that will come out as a result of this, and farming as a service could well see a future in the UK. So I'm going to just talk very quickly about some of the projects we have been involved with, and these are with lots of partners, industry partners and farmers, as well as other organizations. One was rural 5G connectivity. This is really looking at a project that we developed, and I'll talk about it shortly, is the hands-free hectare, which was a world's first to grow a crop without any human intervention. But what we found very, very quickly, in order to do that, we needed machines, multiple machines, but all operating on different frequencies and different communication methods. And so you can see on the left side where there are multiple signals that are required in order to control the machine. And that makes it very, very difficult, and it makes it quite costly as well. And reliability is quite a factor, where we don't want the delay from these signals to be excessive. So moving over to 5G, we will reduce that, what would be 6 potentially different frequencies, different data protocols, to perhaps just 2. And that will give you a better data rates, low latency, so you can act and react to what's happening on the field, and provide you better coverage as well. So that was a project that was with a number of industry partners. Following on from that project, we looked at communications. So in order to communicate with machines, you need to be able to take them out of the farmhouse or the shed and into the field. And we wanted to develop an end-to-end operation. And this was a CAV project along with a number of industry partners, FarmScan Ag and Precision Decisions. And the idea was to deploy some of the technologies being developed in the driverless vehicle area. And this is looking at vehicle-to-vehicle communication, vehicle-to-infrastructure communication, and vehicle-to-people communication, so we can understand people as well. So this was a project that took a tractor out of one of our work sheds and then drove that through a rural path as well as a public path and into a field. And so quite a interesting project that sort of developed the sort of the underpinning foundation knowledge of how we would do communications in a rural environment. Very quickly, mention the hands-free hectare, which was a world's first project about growing a crop, which we successfully did over 2 cropping seasons. So a winter wheat and a spring barley crop, and that was using existing machines. And one of the areas we really focused on was to get the technology adapted to perform these tasks, because Mother Nature, as we know, doesn't wait for anybody. So we used existing technologies that we turned into autonomous machines. So the idea being was we simply replaced the human with a control system, a robot and a computer system, and using existing machinery such as an Iseki tractor or a class combine, we were able to grow a crop and harvest it just using machines. But there are other interesting factors that come along as well. Well, how do you inspect a crop when you're not allowed in the field yourself? So we used drone systems with various types of sensors, multispectral cameras, including a grabber that you'll see here, to look at the crop itself. So that project has now progressed. So we got 35 hectares, which are literally 5 minutes away from where I am, growing wheat, barley, as well as oats. other projects, I'm just conscious of the time. Other projects are underway as well, looking at the application of drone technologies, and especially agri-drones, which are capable of spraying, be it agri-chemicals or stimulants for crops. So there are a number of applications here. Currently in the UK, the spraying of agri-chemicals is not allowed. We're working with the HSE and other agencies to make that happen, so that we can have that available as a commercial service to farmers. So those are just some of the sort of projects we've been involved with. And that has led to other projects where other organizations, other sectors have come along. And in this case, it's a railway sector that have really said, well, if you're using these drones in a rural environment for for farming, could we not use those to help sort of eradicate some of the weeds that we find on our infrastructure? So, you know, there is problems with weeds growing on railway infrastructures, and these could be, you know, high embankments, which are several feet or even hundreds of feet high, where it's difficult to get an operator to. And so we've looked at and we've evaluated the use of drones to spray some of these weeds. Another project that's currently underway is TuberScan. This is a project with another university at Manchester, as well as some of the leading sort of potato growers in the UK, Branston's. And it's the ability to map a crop of potatoes before you harvest. Quite often a farmer would go and manually look at the size of the potatoes and see whether they're suitable for harvesting. But this way we can actually be quite selective on the potatoes that we harvest and look at in detail the size of the crop, and so that we meet the requirements of the retailers. Project just coming to a conclusion that we're looking to take a little bit further now is a AI-based smart crop sprayer. So this will be selective. It uses a 3D sensing camera and an AI process to identify dock leaves, which grow in grassland. And we are able to, and this is with the teaching the system with 5,000 images, which is relatively low for an AI machine learning system. We're able to reach an efficiency of about 98%. So identifying dock leaves within grass to quite a high level of percentage. So those are just some of the sort of projects that we at Harper have been involved with, and no doubt other partners have also similar sort of projects that they can bring as examples. So thank you very much, and I will now pass you over to Ariel.
Thanks so much, Parmjit. Thank you very much. It's fascinating and exciting stuff. Yeah, so Ariel up next. As we mentioned, Ariel is from the British Council based in Israel, and heads up the World Clean Growth Alliance project from here. So he will give you a little bit more information also about how to tap into some funding opportunities around collaborative projects in this area. So I'm going to switch myself off and hand over to Ariel. Thank you.
Hi, good afternoon, everyone, and thank you, Karen. I'm just going to share the screen. Can everyone see that? Yep. This will be a very brief presentation. I'll just give you a background to the World Clean Growth Alliance, and specifically the ways in which it can support projects between the UK and Israel. So a bit of background, the World Clean Growth Alliance was funded by the War Legacy Foundation, a charity based in the UK. It's managed by the British Council in Israel, together with the UK Science and Innovation Network at the British Embassy in Israel. And we also have on board the Israeli Ministry of Science and Technology as a partner. It is a research-focused alliance, and it aims to bring together sort of research-focused collaboration in energy, less relevant here, but also in water and food. And to do so, we have two ways in which we support such projects. The first is we have a flexible grant scheme which awards grants of up to $25,000. There is no deadline for this grant scheme. The funding is open until 31st December 2021, but that's not a deadline. So people you can apply at any time, and we try and get an answer back to applicants within 3 months of applying. Now, it's important to note this isn't research funding. Of course, $25,000 is not the scale at which we could fund research, but really the scheme aims to fund projects at any sort of part of the research to innovation pipeline. So either to promote new collaborations and networks, facilitate ongoing research in other ways, look to applying research either in terms of technology transfer, collaborations with industry, third sector, or policymakers, or to communicate research or work through education, public engagement activities, and so on. And the easiest way, I guess, is to say the sorts of things that we can fund as part of these projects are obviously travel costs, costs relating to hosting and participating in events. We can fund consultancy fees, professional and legal fees, and other similar costs. But again, just to emphasize, we can't fund direct research costs, so materials and equipment and the like, and we can't fund things like academic salaries, student fees, and stipends. To give you a brief example of the sorts of projects we funded recently university, sort of a multi-university workshop, series of workshops around bringing together new research collaborations. So very much at the beginning of a research project. We funded a UK university to visit Israel as part of a larger European consortium and bring in the Israeli partners, so meetings and activities around that and around the specific research sites in Israel. We funded delegations from a university and tech startup to visit the site of the startup's activities and work around potential new research and collaboration around that project. That's an energy generating project there. So it's quite varied. If you have any ideas that you think would fit, then do just get in touch. If you think maybe I'm not sure, please do get in touch, and we can talk about whether it's suitable to apply for funding. And even if you have things that you think fit within the ethos of the Wall Alliance, we have ways of directly funding projects, of partnering on projects, of delivering projects, such as today's event as well, and of partnering with organizations that aren't universities, and so on. So I won't go through this slide. It's just an example of the sorts of things that we can do. But again, do get in touch if you have ideas, if you have things that you want to discuss, and if you think that we might have funding or support that we can offer you. This is me, and these are my contact details. I hope that I guess this will be sent around. There's lots of information on the website, including a much more detailed call for proposals that talks about, again, what we can fund, what we can't fund in the process of applying for grants. Just to note, there's some of the details will be updated hopefully in the next few days. The numbers, the amount of funding and the data might be a little bit out of date on the site, but what I've presented here is now correct. And I think that's pretty much all I have to present to you. I don't know if we have time for questions specifically, or if I'll just take them offline. No, okay, Hadar's shaking her head. We have a tight schedule.
Well, so yeah, we'll get a slap on the wrist from Hadar if we try.
Yeah, so my contact details, do get in touch if you have questions and if you think the funding is relevant.
I'll write out Ariel's contact details in a minute, and Hadar will share.
Actually, I'll put them in the chat. I'll put them in the chat as well.
At this point, I'm going to hand over to Hadar, this name that we've been using, and here she is now, so to lead our panel discussion with our experts. So I'm going to hand over to you, Hadar, and thanks so much, everyone, again.
Thank you, Karen. Thank you, Ariel. Thank you, Parmjit, and thank you, everyone. My name is Hadar Huberman, like everyone already mentioned. I am the head of operations and the UK Israel Tech Hub team, which is based at the British Embassy in Tel Aviv. In a sentence, my team works to stimulate tech partnerships between the UK and Israel in various sectors, with clean growth as one of them. In the past year and a half, I've been the ad hoc leader on clean growth sector in the team, among the rest promoting COP26, like Karen mentioned, and Race to Zero campaign in Israel. I would like to start our short yet very effective panel discussion with our brilliant UK experts virtually sitting with me today. And let's begin with a round of introductions. If you could each introduce yourself, the institution you are representing, your research area and expertise. Dr. Shamal Mohammed, let's start with you. Unmute, maybe.
Yeah, of course, I'm on mute. Sorry, I'll just start again. I'm Shamal Mohammed. I'm a Chief Technical Officer at Agri-Center. So we are one of the 4 agri-tech centers in the UK, and my colleague Matthew from Agrimetrics is in the panel, but we have 2 other centers focusing specifically on animal health and crop and soil health. We at Agri-Center more focus on technology and sensors, and we have a collaboration with our key partners, including Cranfield University, Harper Adams, SIUC, which is the Scottish Rural College, and Edinburgh University, but we also work quite closely with commercial companies. So if I describe or define Agri-EP, and probably it's applicable to other centers, we are enabling the innovation in agriculture. We link in between the science and technology providers, but also linking with the industry and understanding their problems and the pain points, and bringing the right technology and solutions to help farmers to make better decisions, improve productivity and sustainability of their businesses. So we have 4 main locations in the UK, based at Cranfield. We have a facility at Harper in Midland. We also have a facility in Edinburgh, and we also have a commercial farm, a dairy farm in southwest of England, running on a commercial scale, but heavily automated. So I have automated feeding machine, robotic milking machine. We have multiple sensors in the ground to measure various different soil characteristic, grass, animal behavior, milk quality. So we're trying to bring almost like a full package of the data and the flow of information from the soil to the consumer. We also have a phenotyping capability at Cranfield, do a lot of work on hyperspectral imageries, various different application of UAVs. At the moment, we have more than 30 plus projects with Innovate UK, but internationally as well. So we actually leading the Smart Farm initiative in China for 2 years now, 3 years actually. So we work with our partners in China to build and bringing the UK capabilities to the Chinese market. We also have a demonstration farm in Paraguay. We have a project in New Zealand, Ukraine, recently engaged with India and also in Kenya as well in Africa. So we kind of bring in everyone into what we call it as a ecosystem of innovation, and that's what we're trying to do in Agri-Center. Thank you.
Thank you, Shamal. Matthew, why won't you continue?
Thanks, Hadar. Yeah, that's a great idea. Thanks, Shamal, for explaining the agri-tech centres. So the Agrimetrics is one of the 4, and we focus on really those scenarios that depend on data exchange between data owners and data consumers in order to generate that value, whether it's rewarding farmers for making sustainability improvements on farm, or being able to de-risk agri-food supply chains, agricultural finance, those sorts of scenarios. And what we do to enable that is we run a capability, a data marketplace that we call it, that's about enabling that data exchange. And it's informed by or led by the fair data principles. We want it that the data is findable, that as a consumer you can find the data that you need and data that needs to go along with it, and that as a data provider that your data is discoverable. That's the F in fair. A is accessible, that you can actually get the data that you need. We lead with data access over API. Interoperable, and I'll come back to that you can get data, compatible data together, and then reusable. The data is produced for some purposes, can then be put back into the marketplace and people can discover it and consume it. And the key thing is the interoperability, so that you can shop around and get data from multiple different providers, and rather than working with giant data sets from different places or having to slave over data from a sensor, that you can query a field, an agricultural field, and you can get satellite data from certain providers and you get soil data from other providers just simply for that field. And so I sometimes say that if the data acquisition is the first mile, data collection, and the putting the data in a decision support application is the last mile, we do the middle 100 miles. The data marketplace is the process of really making that data work. And we lead the main products and services from that is being able to provide data as a service, so people can just find and pay for just the packages of data that they need over API. A marketplace as a service, a place for people to advertise their data that's managed and supports then the data exchange. Private data exchanges, so enabling that permission data exchange between consortia, like you find in, for example, supply chain scenarios or in research consortia. And finally, professional services. So our software developers, data scientists, and knowledge engineers can go that extra mile with you to actually create the software or create the applications in order to really make that data deliver value and leave you with something to continue forward with. So that's what we do, run the data marketplace at Agri-Metrix.
Thank you, Matthew. Fascinating stuff. Dr. Abdu, please.
Thank you very much. Let me just quickly share a couple of slides. I hope you can see that. Yeah, I think you can see that. I can see. Okay. Well, thank you very much, Hada, for the opportunity. I'm Abdu from Cranfield University. I have a background in hydroclimatological extremes and also in remote sensing, with a broad research interest in combined remote sensing, geospatial data science, and machine learning, to better understand the impacts of extreme weather events and also their compound on the society and also on the environment, including agriculture. So I'm based at the Center for Environmental and Agricultural Informatics, which along with the Soil and Agri-Food Institute provide the largest group of soil scientists in the UK, with expertise ranging from basic soil physics, chemistry and biology, to soil management and conservation, and to soil informatics and resource evaluation. Cranfield is also home to national and international soil datasets, including World Soil Survey Archive and Soil Information System for England and Wales. And Cranfield also hosts world-class facilities such as CHAP Soil Health Facility for simulating soil crop systems to address basically key challenges in soil health management to enhance crop yield. So the Center for Environmental and Agricultural Informatics provide a whole system approach to agricultural and environmental informatics, and includes internationally recognized expertise in agricultural and environmental informatics, remote sensing, and sensor development. And finally, Cranfield experts are using experiments and data from the unique phenotyping sensor platform in partnership with Agri-EP to provide new solutions for improving precision agriculture. Thank you.
Great, thank you, Abdul. Parmjit, we already heard a lot of your activities, but maybe in just one sentence, describe your work.
Yeah, it's always difficult for an academic to describe their work because they'll write a thesis of 8,000 words for you. But yeah, as a Department of Engineering, we look at really 3 strands. So academic programs being the core. We deliver agricultural engineering, but perhaps the only institution in Europe now delivering a B-Engine agricultural engineering. We also have another niche program in automotive engineering too as well, which is all devoted to off-highway. So nothing that goes on the road, but anything outside of a road. And then we do a range of programs on mechatronics and robotics too. The other aspect is on research. So I've mentioned some of the projects that we're heavily involved with, and then tech transfer. So that is where we're working with the likes of the Agri-Epicenters to help businesses develop new product solutions and services.
Okay, great. Thank you. Being very conscious of time, maybe I'll try to shorten the next question that I have. And thank you all. It's such a great privilege to have you with me today. Maybe just a short question about the future of precision agriculture in the UK. Parmjit, you touched that in your presentation. But maybe just to hear from you, panelists, what do you estimate is the extent of use of precision agriculture technologies in the British farmers' ongoing work today? How much do they actually utilize cutting-edge technologies from this sector, from precision agriculture? If anyone wants to go first. Please, Shaman.
Can I go? Yes. Well, I think the term of precision agriculture and the technology itself is include a wide range of items. But I think the latest sort of data from DEFRA and other organizations is around maybe 30% to 40% of farmers. But if you look at the farmers are more and more using some sort of technology, tools, data in decision making, and I think that has become a norm. I mean, it depends on what we mean by precision agriculture, but my understanding is farmers are more and more realizing the value of these tools and digital tools, especially for decision making. But the things we wanted to happen and to see in the industry, which is more toward the digitization. So that's probably the 10% or 20% of the industry are actually pushing very hard for adoption of technology. And that's exactly why in Agri-EP, which I forgot to mention, we have a network of 25 farmers in Agri-EP. And the reason for that is to bring some of this technology tested, evaluated before it goes to the market. And that's good for farmers, it's good for the developer as well, because you can get a real feedback how your software or your algorithm works in detecting disease or nutrient deficiencies. So you need to work with the farmers in order to bring some of these technologies forward. So that's why I think, if you kind of saying, well, what sort of technology? I think most of the farmers, they use some sort of technology in their business anyway. But I think as a precision agriculture, the latest figures from DEFRA, I believe, is around 25 to 30%.
Thank you. Anyone wants to add on top of that? Okay. Oh, yes, please, Parmjit.
Just very, very quickly, just to back what Shamal says, I think what is also a point to note is some of the precision technologies may not be seen as precision these days. They may be seen as taken for granted. If you look at auto steer systems on a tractor, which is quite common now, it may not be seen as precision, but it really is a precision technology. So there are some systems that may have been around for the last 5 or 10 years. They are classed as precision systems, yeah. But for a farmer, they might be thinking, well, it's a little bit old hat and may not quite class it as being precision, but those are still precision technologies.
Well noted. Okay, I'll move forward to the topic, the last topic that we can actually afford ourselves. We have here in the audience representatives from the Israeli Academy as well as the Israeli technology ecosystem, and we would like to encourage the creation of UKIL R&D partnerships around agriculture. So in your opinion, what are the opportunities for this type of collaborations between Israeli and British academies or academies to startups? And if you have a success story to share, please do. Where?
I'll probably start again. Yeah, I think, you know, I mean, this opportunity is fantastic to create that bridge and between a UK academic as well as the agri-tech industry. But in Agri-Epicenter, we already reached out to your agri-tech industry, and then we have a long relationship with Ira, which is he's in the audience. So I think there is a few things we can look at it as a positive. So, you know, agri-tech sector in the UK is backed up by a world-class university. So in terms of the research and the science and the advancement in the science is really something that, you know, agri-tech industry in the Israeli can tap into. I mean, we have an example of Cranfield and Harper Adams, but there are others as well in a different, you know, part of the food supply chain. They have a huge amount of expertise and science. So I think that's quite an important point. And secondly, the UK is a good environment for innovation and in terms of investment, funding opportunities. So that might be something the Israeli companies can consider, you know, building up your capability in Israel and then coming into the UK market. It's not, I mean, UK agriculture is not a massive industry on a global scale, but it will allow you as a launch pad for reaching out to the wider international market as well. So I think these are the kind of the positive sort of points about the UK partnership. But, you know, looking at Israel, they're world leading in technology, and I think that's what we kind of looking for, you know, tapping into some of this expertise and the advancement in technology and the development of this technology and bringing these into the UK agriculture market is going to be a fantastic opportunity.
Thank you, Shamal. Couldn't agree more. Yes, Abdul, maybe you go first.
Oh yeah, I just wanted to. Can you hear me? Yeah, I just wanted to. So echo that, and I think academia and industry or startup collaboration is often a powerful engine for innovation and economic growth, and a good way to turn ideas and innovation into reality. I mean, my collaborations are mostly academy so far, but I tend to seek really to increase working with industry and startups. I think working on specific products that respond to specific client needs is a good measure of research impact as well. And Cranfield University has, I would say, a well-oiled machine when it comes to industry collaborations with its world-class and unique facilities, and also expertise to address industry-wide issues. In fact, 44% of Cranfield's income come from commercial research and advisory services. So really looking forward to collaborate with Israeli startups and this industry.
Thank you, Abdul. Matthew.
Yeah, the common scenarios we see is really making it far easier for the academic community to derive additional value from the insights they create without them having to take on the burden necessarily, and they can if they want, and they could do so more effectively, of starting up a company around it. You know, if we talk about data as the new oil, I think that's an appropriate analogy, because actually the oil is only the start, and you've got to build the refineries, you've got to build the sophistication, you've got to build the algorithms. And innovating the algorithms to get insights from the data is done in the universities. Build the next process-based, good crop model, build the next system that can flexibly work with data from different sensors and devices. But you get that aha moment, you get that innovation, you get that algorithm that works. How do you operationalize it? How do you make money from it? How do you put it out there so that you can commercialize it without you having to maintain your own system and architecture. And really, those are the scenarios that we pick on. For example, with University of Hertfordshire, then they've built a fantastic AI that predicts the optical imagery that you get from Sentinel-2, for example, from the satellites, from the radar data. So you get cloud-free optical, which is wonderful. It just does that. But the academic there doesn't want to necessarily have to build their own company around it. They would want to work on the next problem, but indeed commercialize that IP. And those are the sorts of scenarios that we really target. Or another example, Smart Cow, across research, livestock research institutions across Europe. And we provide that platform for them to advertise the data sets that they have in a rich way, be able to interoperate across them, and for them to hone what the next best research question is to address, or for third parties to then go, oh, there's an expert in this, they've done a study on that. That's where I can get a source of information and start up a collaboration. And again, commercialize the algorithms on top. So they're just the sorts of opportunities we look to make possible where it wasn't possible before.
Thank you, Matthew. Parmjit, do you want to add in a few words?
Yeah, we are working with the Agricultural Research Organization, the Volcani Center, and that is really to get academics to exchange and share knowledge. And this is a great initiative where academics from different institutions can come together, perhaps over a symposium or a conference or a workshop, and really look at the developments of emerging innovations in advanced autonomous technologies. But initiatives like that can be extended to other organizations as well as other academic institutions too.
You do have an excellent example already happening with Israel, as well as Shamal. Thank you, all of you, for your examples. I'm afraid that we have to run to the next bit of the event. I'd like to thank you panelists for taking the time to participate in this event, and great thanks to the audience who joined us. I'd like to, if you'd like to receive more information on our UK experts and the Wall Funding Program, we will send a follow-up email for all of you in the audience who asked, with instructions, with contact information of our speakers. We'll be more than happy if you'll touch base after the event and see what you can do, and maybe you can do great things together. This ends up the first part of the event, which was open to everyone. We're now moving to our three-step one-on-one meetings with pre-selected startups. I'd like to ask UK experts and chosen startups to stay logged in, and to wish all the rest a wonderful afternoon, and hope to see you soon in our future events. Thank you.
Thank you.
Thank you.
Thank you.